Okay, so the data in the table above were produced by a sleep researcher studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes, and Group Y consisted of 100 people who observed later bedtimes. If a person is chosen at random from those who recalled at least one dream, so this is important. This tells us that we're not, right? So we're going to do probability. Probability is always success over total, okay? But the total is not always the grand total. So in this case, we're taking our sample from those who recalled at least one dream. So we have basically this category and also this category. So we're not including the none category. So here are our subtotals, so we can just add those up, and that'll give us our total. So we add 40 and subtract 1, so that would be 65 and then 64. So 164 is going to be our total. Notice that is not the same as the grand total, which is 200. Now we have to find the success. So what is the probability that the person group belonged to group Y? So group Y's total would be these numbers added together. So that would be 79, right? So that is answer choice C. Okay, which of the following best approximates the average rate of change, fancy word for slope, in the annual budget for agricultural natural resources in Kansas from 2008 to 2010? Okay, so from 2008 to 2010, we're looking in this range, and we're looking at agriculture natural resources. So we're looking at these numbers here. We want to know the average rate of change, which is also known as the slope. So to find the slope, we could do a change in Y over change in X. So in this case, the change in Y, we'll use the endpoints 488, 106, and we'll subtract from that 358, 708. That'll be our change in Y. The change in X is just going to be 2 years, right? So 2010 minus 2008. So let's use the calculator to help us out. So we'll have 488, 106 minus 358, 708. That equals this. Then we divide that by 2, and we get 64699. 64699. So about 64,700. 64,700. And notice that these are in thousands of dollars. So we have to add 1,000 onto that. And that gives us choice B. Okay, which of the following, which program's ratio of its 2007 budget to its 2008 budget, 2007 to 2010, so 2007 to 2010 is closest to the ratio for human resources? Human resources is here, okay, so if we divide those numbers, that'll give us our starting value that we're trying to aim towards. So we have basically 4051. I'm just going to leave out the last three numbers, divided by 5921, because we don't need that much accuracy. So 0.68 is approximately what we're dealing with here, 0.684. And now we can just run through the other choices here. So we need to do education. So let's just make a mark here, education. We need to do agriculture, natural resources, and we need to do highways, and we need to do public safety. And we're looking for the one that's closest to 0.684. So let's see. We'll start with the top, 373,904 divided by 488,106. We get 0.766. 0.766. All right. And next group. So we'll do 2164. Again, I don't always have to write all the numbers in as long as I write the same amount of numbers. 3008. Let's see. So that would be 719. 0.719. Getting closer. All right. And then we have 1468 divided by 1773. Let's make it 1774 to round it up. We get 0.82. All right, and then the last one, 2634 divided by 4642. And we get 0.56, so that's way off. So the closest one is just going to be education. And yes, it was a little bit lazy for me to not put all the numbers, but that's okay. Which of the following is an equation of a circle in the xy plane with center 0, 4 and radius with endpoints of this? Okay. So center 0, 4, this one matches up correctly. 0, and this is going to be negative 4. No good. 0, 4, yes. 0, negative 4, no. And okay, so we need the radius length. So the radius with an endpoint of this, so I can use the distance from the center to the endpoint. That will give me the value of the radius. So I have to do a distance formula here. So my change in y is 1 squared, and my change in x is 4/3 squared, and then I have to square root that according to my distance formula. So let's see. 4/3 squared would be 16/9, and then 1 squared is still 1, so that's 9/9. So that's 25/9, and then I have to square root that. So the square root of the top is 5, square root of the bottom is 3. So I get 5/3 for my radius. However, the formula calls for r squared. So r squared is actually 25/9, choice A. The equation above expresses the approximate height, okay. After approximately how many seconds will the ball hit the ground? So that means the height would be 0. So I take this function here and I set it equal to 0. So let's see. I'm just going to approximate this to be 5. All right, negative 5 plus 25t, just for simplicity. Then I'm going to factor out a negative 5. So that makes t squared minus 5t equals 0. And I divide by negative 5, so it just disappears. Okay. And then I could factor out a t, and I get t minus 5 equals 0. T chart, I get t equals 0, t equals 5. And we're looking for the t equals 5. Okay. 26. Katrina is a botanist studying the production of pears by 2 types of pear trees. She notices that type A trees produce 20% more. 20% more then is multiplier 1.2. Than type B trees did. Based on Katrina's observation, if the type A trees produced 144. Okay, so let's start by making an equation here. Type A trees, A, produced 20% more than type B. And type A is 144, so that we could plug that in. And then we could solve for B by dividing by 1.2. And 1.2 is kind of like 12. So you can take 144 and make it 12 times 12. And then divide one of those 12s by 1.2. It's 10 times larger. So that ends up being equal to 120. A square field measures 10 by 10. 10 students each mark a randomly selected region of the field. Each region is a square and has side lengths 1 meter. No 2 regions overlap. The students count the earthworms containing in the soil to a depth of 5 centimeters beneath the ground surface. Results are shown. Which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface for the entire field? So they only sampled part of the field, not the whole thing. So it's a 10 by 10 field. So let's just map it out here. 10 by 10. And what they did was 1 by 1 sections, right? So they did 10 1 by 1 sections, which basically means they did 1 column, okay? And that might not be 10, but that's okay. They did 1 column, so they did 1/10 of the field, okay? So whatever numbers that they got, okay, the total of that would be approximately 1/10, so we'd have to multiply that by 10. Now, on average, we can approximate an average of about 150 earthworms in each region, and there are, so this is one region, there's 100 regions. So I have to multiply this by 100, and then that gives me 150 with 2 extra zeros. So 15,000 earthworms in the entire field.